Okay, guys, we're going to do 5.2 because it's not really learning anything new. It's just putting it together what we did in 5.1. So you need to have all of your identities handy. So what we're doing is we're just verifying trig identities. So we're going to be given something like this where we're equal to, and all the ones that I'm assigning you are going to be equal. You just have to show your work to show that they are indeed identities. So you either just work on the left side or the right side or on both the sides until you get them to equal. So here's the first example, and it has tangent squared x plus 1 on the top here, and on the denominator we have 1 minus sine squared, and these look like Pythagorean identities. So I think I'm just going to go ahead and convert those right away. So the tangent squared x plus 1, that one should be secant squared, so I'll rewrite that as secant squared x. And then the 1 minus sine squared x is cosine squared x. Okay. And then, I mean, we can just keep bringing this down, whatever. I'm not going to rewrite it every time. Since we're looking for it to look like secant to the power of 4x, I think I'm going to change that cosine squared to 1 over secant. So I have secant squared x over 1 over secant squared x. So as you know, when you trying to change the color, as you know, when you divide by a fraction, we can just multiply secant squared x times secant squared x over 1, which then gives you secant 4x, which verifies it. I'm going to click through their work too so you can kind of see theirs. There's their answer. Here's another one. And when I look at this one, I see that I probably want to work on the right side. So I can probably multiply this first term on the right side by the conjugate of 1 plus cosine x. So I'll multiply the top and bottom both by 1 minus cosine x, 1 minus cosine x, and then on the right side I will multiply by 1 plus cosine x. 1 plus cosine x. So the denominator then becomes 1 minus cosine squared x for both of those. The top, you need to distribute. So I have sine x minus sine x cosine x, and then sine x plus sine x cosine x. Oh, we need a different color in here. I don't know what I picked. Okay, so when we combine these two fractions, our denominator is 1 minus cosine squared x, but that is Pythagorean identities, which is sine squared x. So I'm going to change it to sine squared. And then on the top, I have sine x minus sine x here. So these two will cancel. And then I have a negative sine x cosine x minus sine x cosine x. So I have a negative 2 sine x cosine x. All right, so we are trying to get to that cotangent x, that -2 cotangent x. So if we look at this, we're going to see that we can, I'm going to write it so you can see that there's a, we can cancel one of these sine x's. So let me grab a different color again, and we'll get rid of this and we'll get rid of this one. So now we have -2 cosine x over sine x. Well, cosine over sine is cotangent, so we have verified the identity, -2 cotangent x. All right, another example. Okay, all right, we'll do this one. Some of these are going to be long and entailed, and of course everything's going to be a little different. None of these are exactly the only way to do them. So let's start probably on the left side by multiplying. If I multiply that by the conjugate, sorry, I can't speak. If I multiply the whole left side by the conjugate, we would multiply top and bottom by secant x plus 1, secant x plus 1. So there, the denominator is going to be secant squared x minus 1. And the top, I think I'm going to not, yeah, I'll distribute it. I don't know. So if I distribute it, I get sine x, secant x, plus sine x. I think I remember this one being as long and difficult, so yay. There's a Pythagorean identity there, the secant squared x minus 1, which is tangent squared x, so I'm going to write that in. I think that if I change, I think I'll, shoot. Yeah, it'll be fine. I think I will change the secant x into 1 over cosine x. I'm trying to think if I want to do that right away or not. Yeah, I guess I will. Okay, so sine x times 1 over cosine x plus sine x. Okay, I'm going to rewrite that then as sine x over cosine x, just combining that product, plus sine x over 1. And that's my numerator. And then my denominator, I'm going to change tangent squared to sine squared over cosine squared. Okay, so in the numerator part here, I'm going to combine these two fractions, getting the same denominator. So to get the same denominator, I have to multiply this one by cosine x on top and bottom, which I'm just going to write it up here. So when I combine the numerator of this whole thing, we have sine x plus sine x cosine x over cosine, whoops, and then that's all over sine squared over cosine squared. So I'm going to take this numerator and multiply by the reciprocal. And I think because I'm not going to be able to cancel this out unless we have factors, I think I'll factor out a sign here. So if I factor out a sign, then I'm left with 1 plus cosine x. I'll just get rid of that and then grab another color. Okay, so now I can start cross-canceling here. So I can take out one of these sines and one of these cosines. So then I have 1 plus cosine x times cosine x. So I'll write it down here. 1 plus cosine x times cosine x over sine x. Actually, let's forget that for a second. I think if I change this right away to cotangent, that's going to make more sense. I was just looking at what we have to get to. So I'm going to change that to cotangent and change my colors again. So right now I have that 1 plus cosine x in parentheses, and I'm multiplying it by cotangent x. Now when I distribute the cotangent, I'm going to get cotangent x plus cosine x cotangent x. And that is exactly what we're trying to get to. So we could have got it this way too, but it just would have been a little more difficult. Okay, so I hope that your problems are not that difficult, but I am going to make up a key since mine's at the school and I don't want to go out. I think I'll make up a new key and post it for you guys so that you can look at my work as you go through this, and hopefully that'll help. I'll see what else we have. Oh, they left it in secant form. I'm not good with that. I like working with sines and cosines better. Theirs was very long too. Okay, this one I think we'll start by factoring, especially since it says up here, factoring. So if I look at the left side of the equal sign, I'm going to take out a cosine x tangent x because my GCF is cosine tangent. Since it's in both the terms. So when I take it out of this first term, I'm left with secant squared. And when I take it out of this term, I'm left with tangent squared, so minus tangent squared. Well, if I look at my Pythagorean identities, secant squared x minus tangent squared x just equals 1. Okay, so now all we have is cosine x times tangent x. And tangent we can rewrite as sine over cosine. So I have cosine times sine over cosine, which very nicely cancels out, and we just get sine x, which is what we wanted. Yay, that one was way better. I think I'm going to stop there. And I think I'm going to look, but I don't think you guys have any quite this bad. Well, no, I don't think you do. But I'll have the work written out anyway. Oh yeah, they're just working from both sides. This is super complicated, at least to me. Here's some strategies. You can read through these. I think the important ones are like right here where it says to, use the conjugate to create a Pythagorean identity if you have a 1 plus something or a 1 minus something. And then you know, just to keep checking your reciprocal identities, your Pythagorean identities. And this one, I don't know why it's listed last. It says if no other strategy presents itself, try converting the entire expression to one involving only sines and cosines. I actually tend to do that early on. If I don't see anything that jumps out at me right away, I do that. But like I said, I do like working with sines and cosines. So good luck. Maybe I'll write your assignment down here. Maybe I won't. I don't remember what it is. I think it's numbers 2, 6, 14, 16, 20, 22, and 26. And that page number is 324. Okay, good luck, and I guess we'll see you when we have school again.